Good morning, students. Today we are going to study the second chapter, that is inverse trigonometric functions. Now here it deals with two new terms which are inverse and functions. Now we are already aware of that if f is a function from x to y such that fx equal to y, and if it is given to be 1, 1 and on 2, then we can define a unique function g from y to x such that gy equal to x, where x belongs to x and y, which is equal to fx, belongs to y. That is, if f is a function from x to y and g is a function from y to x, such that what's so special about these functions? That domain of g, which is y, it happens to be the range of f, whereas the domain of f, which is x, it is the same as the range of g, which is x. The function in such a case, the function g is called the inverse of f and is denoted by f inverse. That is, g is equal to f inverse. Further, now g is also 1, 1 and on 2, and so the inverse of g is f. And how do we get this? You can clearly see that g inverse is, in place of g we will write f inverse, it becomes the inverse of f inverse, which is f. So what do you observe here? That in such a scenario where f is a function from x to y and g is a function from y to x, such that fx equal to y and gy equal to x, we observe that g is f inverse and f is g inverse, and this is possible only if both f and g are 1, 1 and on 2. Okay. Now we have to now consider the trigonometric functions. Okay. Now for that, we know that all these functions are periodic in nature, that is, they repeat themselves after a fixed interval, and so they are not 1, 1. And how do we realize this? We know that sine of 2 pi plus theta is sine theta and cos of 2 pi plus theta is cos theta. Now it means that every angle which comes after every cycle of 2 pi will give you the same value of sine and the same value of cosine. Now, so clearly they are not 1, 1 but many to 1 functions. Now, for their inverses to exist, we have to first make them 1, 1. And same thing follows for the remaining 4 trigonometric functions also. Now let's first consider the sine function and its graph. Now let's consider y is equal to sine x. We know that the graph of sine function is somewhat like this, that is, when x is 0, sine is 0, x is pi by 2, sine is 1, and so on. Now we see that the entire value of sine x lies in this band of -1 to +1, that we know that sine x always lies between -1 to +1, and that's why we call the range of sine as -1 to +1. Now if you just segregate this into small intervals, like what we have to do now is to restrict the domain in such a manner that it now becomes 1, 1 and on 2. And for that, what we can do is we can segregate or restrict the domain to minus pi by 2 to plus pi by 2. Similarly, from here to here, or from 3 pi by 2 to 5 pi by 2, and so on. Similarly, on this side, minus pi by 2 to minus 3 pi by 2, minus 3 pi by 2 to minus 5 pi by 2, and so on. So, all these small segments of this domain, if you just take any one of them, the range still remains. See, you can see that here all the values from minus 1 to plus 1 are already, they are there in this domain when x is from minus pi by 2 to plus pi by 2. Same way, when it lies between pi by 2 to 3 pi by 2, all the values lying between minus 1 and plus 1 are there. Similarly, it repeats. So, if you restrict the domain to any one of these small branches, the function sine becomes now 1, 1, and of course, it is already on 2. But what we do is we prefer that branch which contains the first quadrant, and that's why we restrict the domain to minus pi by 2 to plus pi by 2. Similarly, in case of cosine function, the graph is somewhat like this, and the entire value or the range of cos x is between minus 1 to plus 1. Again, if you restrict the domain to 0 to pi, or to pi to 2 pi, or 2 pi to 3 pi, and so on, all the values lying between minus 1 and plus 1 are already taken into consideration. And so, also in each of these branches, the function now becomes 1, 1, and it's already on 2. Again, as I had already mentioned earlier, we prefer taking that branch which considers the, or which takes into consideration the first quadrant, and so in case of cos, we restrict the domain to 0 to pi, and then it becomes 1, 1 and on 2. Such restrictions of the domain of cosine as well as sine, they make the function, both the functions 1, 1 and on 2, and hence invertible. And this small segregation or restricted domain, that is minus pi by 2 to plus pi by 2 for sine and 0 to pi for cosine, makes it invertible, and this branch is called as principal branch. Now, the inverse of sine x is written as sine inverse x and not as sine x whole inverse. Reason is that if you just write it as sine x whole inverse, it is nothing but 1 upon sine x, which is cosec x, and definitely cosec x is not equal to sine inverse x. They are two entirely different functions. Same way, the inverse of cosine x is written as cos inverse x and not as cos x whole inverse, which again on the same lines means 1 upon cos x, which is sec x, and definitely sec x is not equal to cos inverse x. So, this is how we write sine inverse x or cos inverse x. Same way we write tan inverse x, cot inverse x, cosec inverse x and sec inverse x. Now, let us first consider the domain and range of sine and cos, the restricted domain and the range of sine and cos, and hence that of sine inverse and cosine inverse. Now, we know that sine inverse x has the domain all real numbers, that is R, and the range is -1 to 1. But if we restrict this domain to minus pi by 2 to plus pi by 2. Now this becomes 1, 1 and hence invertible. And in that case, sine inverse is defined. Now we know that if G is the inverse of f, then this is possible only in case f is from x to y and g is from y to x. That is, the domain of f is the same as the range of g and the domain of g is the same as the range of f. So, same way here, if sine inverse x is defined, then the domain of sine inverse would be minus 1 to 1, which happens to be the range of sine x. Same way, the range of sine inverse x will now become the restricted domain of sine x, which is minus pi by 2 to plus pi by 2. We call this as the principal range of sine inverse x. Similarly, for cos x, the domain is sine r and the range is minus 1 to plus 1. But if we restrict the domain of cos x to 0 to pi, then this function now cos x becomes 1, 1 and hence invertible, and so cos inverse x is possible or defined. Now to see its domain and range, again the same thing follows, that the domain of cos inverse would be the same as the range of cos, which is minus 1 to 1, and the range of cos inverse would be the same as the restricted domain of cos, which is 0 to pi. Again, just like sine inverse x, the range of cos inverse x is also called as the principal range. Now let us see that what is the use of this, how are we going to use this principal range or of sine inverse x and cos inverse x. It helps us in finding the principal value of certain problems. So let's consider those cases. Now suppose we have to solve the find the principal value of sine inverse, let's say half. So what we do is, we suppose it to be x. Okay, so let sine inverse half be equal to x. This gives us sine x equal to half. This sine goes this side, it becomes sine inverse becomes sine, so sine x equal to half. Now exactly as we did in class 11, we will write it as what value of x gives sine x equal to half. There sine x is positive in the first and the second quadrants, and so you will get two values. One is pi by 6 and the other one is pi minus pi by 6. This gives us x equal to pi by 6 and 5 pi by 6. Now here comes the role of the principal branch of or principal range of sine inverse x. We will report only that value which belongs to the principal range. Now clearly out of these two, pi by 6 belongs to first quadrant, and so we write x is equal to pi by 6, which belongs to minus pi by 2 to plus pi by 2, and we drop this value. Same way, if we have to find the principal value of cos inverse half. So again the same way we write, let cos inverse half equal to x, which implies that cos x equal to half. Now again, as we did last year, we look for those values of x which make cos as half. So clearly cos is positive in the first and the fourth quadrants, and so you write cos of pi by 3, and it is also equal to cos of minus pi by 3, which gives us x equal to pi by 3 and minus pi by 3. And this, now again we have to choose that value of x which belongs to the principal range. Now principal range of cos inverse is 0 to pi, means first and second quadrants. And so the value which satisfies this is pi by 3. So we drop this value and report the answer as x equal to pi by 3, which belongs to 0 to pi. Isn't it easy? And it's very scoring also, and you do get 1 markers or 2 markers on questions of this kind. Thank you.